Hello and welcome to Quick Maths Revision, where today we're going to be going over some of the maths behind the exact trigonometric values. So by that, I mean where these numbers from this table come from. So in my previous video, I showed a really easy way to be able to remember how to fill out this table. So go and check that out if you're looking for an easy way to be able to fill it out. And then you can come back to this and you can see where the numbers actually come from. So what I'm going to do is I'm going to use triangles to explain where these come from, so for these values, and then I'm going to use the graphs of sine, cos and tan to explain for the other two rows. So the triangles I'm going to use are quite specific. We're going to have one of them that will have a degree of 60 in this angle here is 30 degrees, and then the lengths are 1, root 3 and 2. And then if we use Pythagoras, you can see that this is indeed a right angle triangle and the numbers hold up. So if you're in an exam and you can't remember the method that I gave in the other video, you can always draw out these triangles. And what you'll notice is that this triangle in here will give you the answers to this row and this row, as it contains the angles 30 and 60. Let's go straight away and see what we're going to do. So as we're using trigonometric functions, we're going to use trigonometry to be able to get our answers. So we're going to do sine of 30. So 30 is this angle here, and we know that using SOH CAH TOA that sine of the angle is the opposite over the hypotenuse. So for this angle here, the opposite is 1 and the hypotenuse is 2. Nice and easy. So now we're going to do cos of 30. Change the colour of the pen. So we're looking at this angle here, and we're going to do cos of the angle CAH is adjacent over the hypotenuse. So the adjacent is this one, and the hypotenuse is this one. So the answer is root 3 divided by 2. And then finally, tan 30. So we've got that tan of the angle is the opposite over the adjacent. So for this angle here, the opposite is this 1 here, and the adjacent is this root 3 here. So 1 over root 3, which is root 3 over 3 when you rationalise the denominator. So let's just do a quick check. So sine of 30 is a half, cos of 30 is root 3 over 2, and tan of 30 is root 3 over 3. So that's right. That's good. So now what we can do is we've looked at the 30-degree angle, and what we'll do instead is we'll take a look at the 60-degree angle now. Okay, so using similar trigonometry, we're going to do sine 60. We know that sine of the angle using SOH CAH TOA is the opposite over the hypotenuse. So now we're looking at this angle here. So the opposite is this, and the hypotenuse is this. So we're going to have root 3 divided by 2. So for cos 60, we have CAH, so that's the adjacent over the hypotenuse. And then what we'll do is, looking at this angle, the adjacent is the 1 and the hypotenuse is the 2. So we get half. And then for tan 60, tan of the angle is the opposite over the adjacent, so that's TOA. And then what we'll do is, got this angle here, the opposite is the root 3, the adjacent is the 1, so we get root 3 divided by 1, which is square root of 3. And then if we compare that again, we're going to get, in the table, sine of 60 is root 3 over 2, which is what we get, so that's good. Cos of 60 is a half, which is what we get, and tan of 60 is root 3. Marvellous. So that's all we're going to get from this triangle. So if we look at this separate triangle here, so this one is a bit different to the other example. So both of the angles are 45 degrees here, and this one's obviously 90 in the other corner, and the straight lines going through these sides here show that they're the same length. So this is an isosceles triangle with 2 angles that are 45 degrees, and then obviously the right angle. So using a similar idea, it doesn't really matter which angle we look at because they're both the same. This triangle has lengths 1, 1, square root of 2. So using Pythagoras again, we can see that this triangle is correct. So what we're going to do is we're going to be able to do what we did before. So sine 45. So that's opposite over hypotenuse. So we're here in this corner. The opposite is the 1, and the hypotenuse is this root 2. Let's get 1 over root 2, which is root 2 divided by 2 once you've rationalised the denominator. Okay, so let's look at the other ones. So we've got cos of 45 now is what we're going to do. So that's CAH, so that's the adjacent over the hypotenuse. So we're looking at this angle here. The adjacent is the 1, the hypotenuse is the root 2. So we're going to get the same answer as for sine 45, which is square root of 2 over 2 once we've rationalised the denominator. So tan of 45, SOH CAH TOA, we've got opposite over adjacent, and change the colour. So we're in this corner here, and the opposite is the 1, the adjacent is the 1, so we've got 1 over 1, which is 1. So from our triangle here, we've got root 2 over 2, root 2 over 2, and 1, and when we look at our table, we've got root 2 over 2, root 2 over 2, and 1. So that means that we're sorted. So that's all we're going to get from the triangles, and we've managed to complete these 3 rows here. So if you're in an exam and you can't remember the method from before, draw the triangles out. As long as you remember the sides and the angles, you can always derive these values for the table as well. So if you're in a bit of a sticky situation and you can't remember the method I did before, just draw the triangles, because you'll always get it right as long as you draw the triangles correct. So for the other ones, so we're looking at 90 degrees and 0 degrees, I find it easier to look at the graphs of the functions. So if we draw them out now, so this is y equals sine x. We'll draw the next ones. That one's y equals cos of x. And this one's going to be y equals tan of x. So just draw the asymptote on there. And now what I'll do is I'll have a look at this here. So this graph here runs from minus 360 to 360 degrees. And it has a peak of 1 and a lowest point of minus 1. And the same goes for this graph here. It goes from minus 360 to 360 degrees. So I'll look at sine and cos first, and then we'll look at tan afterwards, because that's a little bit different. So what I'll do is I'm going to mark on every 90 degrees. So I'll do that in red, just so you can see it. So that's 0, 90, 180, 270, 360, minus 90, minus 180, minus 270, minus 360. And I'll do the same for the cos one. If I can draw a bit of a straighter line. 0, 90, 180, 270, 360, minus 90, minus 180, minus 270, minus 360. All right, so now we're trying to look at what does sine 0 equal? And what does sine 90 equal? So to fill out those values in the table, we can just look at the graph. So at x equals 0, so this is our x-axis here, and this is our y-axis. At x equals 0, y also equals 0. So the answer is like sine 0 is 0. And then when x equals 90, y equals 1. So sine 90 is 1. So that's good. And now we'll do the same for the cos graph here. So we're looking at what does cos 0 equal, and what does cos 90 equal. So when x equals 0, y equals 1. So cos of 0 is 1. And then similarly, when x equals 90, so this first red line, y equals 0. Do that in a black pen. There we go. So now when we look back at our table, we'll know that sine of 0 is 0, cos of 0 is 1, and sine of 90 is 1, and cos of 90 is 0. So that's nearly all of the values sorted. And now we're going to have a look at tan of x. So as I said, tan's a little bit different. This is our x. This is our, that's not. It's completely wrong. That's a y, and that's an x. So this is 0 here. This is 90. This is 180 there, and that's 270. This is minus 90, that's minus 180, and that's minus 270 there. So, when we look at this graph here, we're going to do the same as what we did. We're trying to find out what is tan of 0 and what is tan of 90. So when we go along, when x is 0, y equals 0. So that's nice and easy. Tan 0 is 0. Tan 90 is rather unusual. So 90 degrees, when we go along x equals 90, we get to this point here, which is on the asymptotes, this dotted line. And what an asymptote is it is a line that your graph will never actually touch. So as x gets really close to 90, as you're approaching from this side here, this graph goes off to infinity, but it'll never actually touch this point. It just tends off to infinity. And if we look at it from the other side, if you're going towards 90 from the right, it tends off to negative infinity, and it goes all the way down to negative infinity, and that won't touch it either. So it doesn't actually have a value at the point x equals 90, which is why we say that tan of 90 is undefined, as it doesn't actually have a value, because the graph never actually touches the point when x equals 90. And with those two values, we now know that tan of 0 is 0 and tan of 90 is undefined. And with that, using our triangles and graphs, I have hopefully explained as to where these values come from. And if you're ever stuck in an exam, be sure that you know, if you can't remember the method, you can always draw a graph or draw the triangles and work it out that way. So I hope you found this useful, and if you want just an easy trick to remember, be sure to check out that video I mentioned earlier where I just teach you how to fill out the table quite quickly. But hope you found this useful and interesting, and be sure to check out some of my other videos.